All right, 9.4. So last section in chapter 9, last section before your next test, which will be interesting considering the fact that we're doing all this stuff, through Canvas and everything. But anyway, let's talk about 9.4. So 9.4 is just a summary of the rest of chapter 9. And so here's what we've talked about. In chapter 9, we talked about constructing confidence intervals for various different kinds of parameters, right? So we talked about confidence intervals for proportions, means, and variances, and therefore standard deviations as well, right? You're welcome to use Statcrunch for all of this, right? So you don't have to use the formulas that we derived in class. The main reason that I gave you those examples was just because, as I've said many times in class before, I don't like you coming away from this class with the feeling that there was no math going on with what you were doing. These things aren't guesses. They're not guesses. This is actually mathematically sound. It's just that we let Statcrunch do a lot of the calculations for us because they're kind of tedious, right, to do by hand. Anyway, so on this first page, I just have the Statcrunch procedures that you should follow in order to construct the confidence intervals that you need to construct, right? I just want to point out that it's fairly intuitive, right? If you want a confidence interval for the proportion, you're going to go to stat and then proportion stats, okay? And I don't know why it says proportions there. It should say proportion stats, right? So you go to stat, proportion stats. If you're constructing a confidence interval for the mean, you go to stat and then t-stats. Why t-stats? Well, t-stats because we use the t-calculator to get the critical values needed to compute the interval, all right? So it's stat t-stats for the population mean. And for the population variance, you go to stat variance stats. Okay, so pretty straightforward for proportion, stat proportion stats. For variance, stat variance stats. For mean, that's the only one that you have to remember. You have to go to t-stats. But the reason, again, it might help you to remember why you do that if you remember the reason for it. The reason for it is because we follow students' t-distribution to get those critical values. In each case, we haven't really focused on this in a ton of detail, okay? But in each case, before you construct these intervals, you have to make sure, you have to check some conditions, okay? And the conditions that you check on each of them is a little bit different. If you want to construct an interval for the proportion, okay, you have to check to make sure that p hat is normally distributed, okay? This happens if n times p times q is bigger than or equal to 10. You also have to make sure that we can assume independence. And this happens if little n is less than or equal to 0.05 times capital N. Okay. Ooh, excuse me. If you want to construct a confidence interval for the mean, well, then you have to make sure that x bar is normally distributed. That can happen in a number of different ways. X bar is normally distributed if the sample size is large enough, in particular, if n is at least 30. Or it could happen that x bar is normally distributed if the data comes from a population that's normally distributed with no outliers. So to check if that's the case, the problem might simply say so, right? If the problem doesn't say so, but it gives you actual data to work with, then you can put the data into Statcrunch, make sure that it's normal with no outliers by looking at a probability plot, right? Graph QQ plot, and by looking at a box plot to check for outliers. And then the other thing you have to make sure of is that we can assume independence. Again, this happens if n is less than or equal to 0.05 times capital N. For confidence intervals for the variance, there's only one condition to check, and it's a pretty strict condition. You have to make sure that the underlying population is normally distributed. It doesn't matter how large the sample size is. If the underlying population is not normally distributed, then you cannot compute this confidence interval. The other thing to point out about this confidence interval is that if you want to, this gives you a confidence interval for the variance. If you want an interval for the standard deviation, then you need to compute this interval, but then take the square root of the upper and lower bounds, right, to get your confidence interval for the standard deviation. Okay, so with that, let's take a look at a few examples. And again, I'm not really going to emphasize the formulas here. I'm just going to do this in Statcrunch, okay? So number one says a Gallup poll of 547 adult Americans asked whether or not they considered their commutes to work to be stressful. Gallup reported that 24% said that their commutes were stressful. Construct a 95% confidence interval for the proportion of Americans who consider their commutes to work to be stressful. Okay, well, if we're checking conditions here, then first of all, we need to make sure that n times p times q is bigger than or equal to 10. Well, let's see. It looks like our sample size was 547, right? It was a poll of 547 Americans. So n is 547. It says that Gallup reported 24% of their commutes, or reported that 24% said their commutes to work were stressful. That's our sample proportion, but since we don't know what the population proportion is, it's our best guess for P. So we're going to use 0.24 for P. If P is 0.24, then Q, well, Q would be 1 minus 0.24, that's 0.76. Okay, we want to know if this is bigger than or equal to 10. So I'm going to punch that into my calculator. I think it probably is. Yeah, this comes out to about 99.77 and some change, but it's definitely bigger than 10, so that condition holds. The second condition we have to check is that little n has to be less than or equal to 0.05 times capital N. And see, here we're a little bit stuck because we're not told what our population size is. We are told what our population is. Our population is adult Americans. So you could Google like how many adult Americans there are if you wanted to. But I think it's pretty safe to say, there are hundreds of millions of adult Americans. And I think it's pretty safe to say that 547 is less than 5% of that. So, so this condition pretty much holds. And in fact, it's pretty much always going to hold. Honestly, it rarely, we rarely fail to meet that condition. Okay, since the conditions hold, we can go ahead and construct the interval. So to do that, we're going to go to Stat, Proportion Stats, one sample with summary. Okay, once we go there, we'll be prompted for the number of successes and the number of observations. We actually weren't told what the number of successes were directly, right? We weren't told like, 16 people said yes. No, instead we were given a percentage. We were told 24% of people said their commutes were stressful. Well, 24% of what? It's 24% of the 547 people who were asked, right? So to get X, we could say, well, the number of successes was 24% of 547. Whoops. So let me see how much that is. So 0.24 times 547. That's about 131. So I'm going to say X is 131. So they're going to prompt us for the number of successes. They're going to prompt us for the number of trials. It's 547. They're going to prompt us for the confidence level. In this case, we want a 95% confidence level. Let's see what we get. So I'm going to go to stat, proportion stats, one sample with summary. I'm going to say we had about 131 successes out of 547. Whoops. 547 observations. We want a 95% confidence level. There's my interval. I'll round those values to 3 decimal places. All right, so to 3 decimal places, we'd say, all right, so that's 0.204 to 0.275. Okay, and that's it for that one. If you were doing this on a test or a quiz, this is exactly the work that I would want you to show. Okay, if I asked you to check conditions, then you would do this top part. If I say don't check conditions, just construct the interval, then do this part. If I ask you to do both, I would probably ask this in part A and this in part B, right? But anyway, this is exactly what I would want you to write down on a test or a quiz, not just the answer, right? Write down all of the stuff. Write down where you go in Statcrunch, right? And write down what you enter into Statcrunch to get your results. That's what I want to see, okay? Now in this problem, I didn't ask us to interpret the interval, but I think it's worthwhile to pause and think about what we just did, right? So let's interpret the interval just verbally. We won't write anything down, but verbally we would say, all right, this is a 95% confidence interval for the proportion of people who feel their commutes to work are stressful, right? We know for a fact that 24% of people in the sample said their commutes to work were stressful. But the question is, if we were to ask every adult American about their commute to work, what percentage would think their commute is stressful? And the answer is, well, we're 95% sure that somewhere between 20.4% and 27.5% of people would say that their commutes to work are stressful. Okay? And that's the interpretation there. Let's move on, look at another example. So looking at number 2. Okay, this one says a random sample of 10 people was asked if winter was their favorite season of their year. Their answers were no, 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 yes, no, yes, no, 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 no. Construct a 99% confidence interval for the number of people whose favorite season of the year is winter. I think instead of number, we should say proportion. So for the proportion of people whose favorite season of the year is winter. It says assume that conditions for constructing this interval hold. Okay, so we're not going to check conditions this time. We're just going to go ahead and do this. To do this in Statcrunch, we would go to Stat, Proportion Stats, one sample. This time we're not going to say with summary, we're going to say with data, because we have the raw data, right? Here it is. In this case, only 10 people were asked their opinions, so there's not a ton of raw data to look at, but that's what it is. That's the raw data right there. So we're going to say with data. Okay, so let's go ahead and the rest is going to be done in Statcrunch. I mean, we do need to tell Statcrunch we want a 99% confidence level, so maybe I'll write down confidence level is 99%. But the rest of the stuff just comes from the data that we enter. So let's go to Statcrunch now and enter that data. I'm just going to write N for no, Y for yes. No, no, no. Yes, no, yes, no, no. Oh, I missed something. Oh, shoot, up here. This is a no, so I need one more yes. It doesn't matter if they're in the right order or not, so I'm just going to put that there. Okay, so we go to stat, proportion stats, one sample with data. Okay, I need to make sure I change my confidence level to 99%. Uh-oh. Oh, yeah, I've got to tell it what success is. Success is a yes, which I just called capital Y. Okay, here's my confidence interval. So the confidence interval I'm getting is negative 0.126 up to 0.526. Now, hopefully you're looking at this interval and you're thinking to yourself, this is really weird. There are a couple reasons that you might be thinking that. There are a couple reasons you should be thinking that. One of the things that's weird about this is that our lower bound is less than 0. That's a strange thing, because if you're talking about what proportion of people have some kind of characteristic, the smallest it can ever be is 0. It can never be negative, right? It doesn't make sense to say that negative 12.6% of people think winter is their favorite season of the year. Like, what would that even mean, right? Negative 12.6. That doesn't make sense, right? The smallest it could be is 0. And in fact, here we had 2 people respond yes. So we know that it's not 0. We know it's got to be actually bigger than 0. So in reality, when we give our answer, a better answer would be, well, since this goes all the way below 0, but the smallest the population proportion can ever be is actually 0, I'm just going to say 0 up to 0.526, right? And that's what I'm going to give as my answer. I'm not sure which one Statcrunch would accept. On a test or a quiz, I think I would be okay with either one, because this is kind of a tricky thing, but definitely the bottom answer is better, okay? The other thing that's kind of strange about this is that look at how wide the interval is. Even when we cut off the bottom end so that it starts at 0 instead of dipping down into the negative numbers, even then the interval is pretty wide. There are a couple reasons that the interval is so wide. For one thing, we had a really small sample size. Okay. For another thing, we had a really high confidence level. We wanted to be 99% sure. And remember, we said the more sure you want to be, the wider your confidence interval needs to be. We also said the smaller your sample size is, the wider your confidence interval is going to end up being. So here we have a perfect storm where we have a large confidence level and a small sample size. That's going to lead to a result that's basically meaningless, right? We're saying that, basically we're saying that somewhere between nobody and more than half of people think that winter is their favorite season of the year. That's just not useful, right? We need more information, and we can maybe stand to be a little less confident in our results if we're going to have such a small sample size, right? But that's the idea there, okay? So moving on, let's look at another one. Okay, this one says a random sample of 15 movie patrons results in a mean IQ score of 103.0 and a standard deviation of 14.7. The 15 IQ scores appear to come from a normally distributed population. Okay. Part A says construct a 95% confidence interval estimate of the mean IQ of all movie patrons. Well, the good news is, so we want to construct a confidence interval for the mean. We don't have to check conditions here because we were told point blank that the IQ scores come from a normally distributed population. So therefore, X bar is also going to be normally distributed. So we can go ahead and construct the interval. We're going to go to stat. Now we want a confidence interval for the mean, not for the proportion, right? So we're not going to go to stat proportion stats this time. This time we're going to go to stat t stats, right? That's where you go to construct an interval for the mean. So we're going to go to stat, t-stats, one sample, and I don't have raw data. I have a summary of the data. So I'm going to say with summary. When I go there, I'm going to be prompted to enter the sample mean. I'm not sure what order they ask for these things in, but they definitely ask for the sample mean. In this case, we're told that this random sample had a mean of 103. We're going to be asked for the sample standard deviation. We're told that it had a mean of 103 and a standard deviation of 14.7. We're going to be asked for the sample size. Well, here we had a random sample of 15 movie patrons. And then we're going to be asked for the confidence level. And we're asked here for a 95% confidence level. So I'm going to say confidence level equals 95%. Okay, let's go to Statcrunch, see what we get. We're going to go to stat, t-stats, one sample with summary. Okay, sample mean is 103, standard deviation, sample size, and we want a 95% confidence interval. All right, there it is. So I'm going to round this to 1 decimal place, and I'm going to say the mean IQ score is going to be somewhere between 94.9 and 111.1. Okay, and that's my answer there. So thinking about what this means, right? We're saying we know for a fact that in this particular sample of people, the mean IQ score was 103. But if we looked at all movie patrons, in other words, if we look at everyone who watches movies, which is most of us, right? And we measure their IQ scores, what would the mean IQ score be for all movie patrons? And we're saying, well, we're 95% certain that the true population mean is somewhere between 94.9 and 111.1. That interpretation is useful when we think about part B, which asks, can we safely say that movie patrons have a mean IQ score greater than 100? Okay, so pause the video, give that some thought. Can we safely say that movie patrons have a mean IQ score greater than 100? Okay, so here's my answer. I'm going to say definitely not. Right? We cannot safely say that movie patrons have a mean IQ score greater than 100. Why? Well, because look at our confidence interval. We have values less than 100 in this interval. For example, the mean IQ score might be 97, right? 97 falls within our 95% confidence interval. So there's no reason to think that 97 might not be a possibility, right? So no, it's not at all safe to say that movie patrons have a mean IQ score greater than 100. So we say no. No, because the confidence interval, I'm just going to CI, confidence interval contains IQ scores that are less than 100. So no, it's not safe to say that the mean IQ score is greater than 100. Okay, so that's it for part B. Part C says, construct a 95% confidence interval for the variance and the standard deviation of the IQ scores of movie patrons. Okay, we find both of these in the same place, right? We have to go to stat, variance stats, one sample, with summary. When we go there, we'll be prompted for the sample variance and for the sample size, okay? So for the sample variance, now notice, this is something that messes students up all the time. Notice that here we were given the sample standard deviation, right? We were told the standard deviation is 14.7. Well, the standard deviation is the square root of the variance, or in other words, the variance is the standard deviation squared. So if we're prompted for the sample variance, then we're not going to put in 14.7. We're not going to put in S equals 14.7. We're going to put in S squared equals 14.7 squared. Now, you can actually type that directly into Statcrunch, and I'll show you that in a second. If you're not comfortable typing this directly into Statcrunch, then just punch this into your calculator, right? If you punch in 14.7 squared, you get 216.09, and so you can just put in 216.09, right? But just the moral of the story is be careful. If they prompt you for the standard deviation, put in 14.7. If they prompt you for the variance, put in 14.7 squared, right? So be careful. And then the sample size was 15. Okay, let's see what we get. So I'm going to go to Stat, Variance Stats, one sample with summary. Sample variance is 14.7 squared. So I'm going to put 14.7. And then if you look at your keyboard, if you look at the 6 on your keyboard, there's a little triangle looking thing above the 6. So if you hold down Shift and hit 6, then you get that little triangle symbol. We call that a caret. So I'm going to put 14.7 caret 2. That's 14.7 squared. Again, if you don't like this, right, if you're confused by it, then just put 14.7 squared into your calculator and put that number in here instead. All right, now the sample size is 15. We want a 95% confidence interval. So I hit compute, and there it is. You see that they actually do that computation, 14.7 squared, 216.09. So they do the computation for you. Here are our lower and upper bounds for our confidence interval. This is a confidence interval for the variance, sigma squared, right? So I'm going to say something like this, right? For sigma squared, the confidence interval rounding to 2 decimal places, or to 1 decimal place, I would say is 115.8 to 537.5. For sigma, well, I'm going to take the square root of those numbers, right? So I'm going to do square root of 115. And actually, I'm going to use the full number. So I'm going to say square root of 115.82626. Square root of 537.46797. Let's see about how much that is. So this I just have to do on my calculator, right? Square root 115.82626 is about 10.8. Square root of 537.46797 is about 23.2. Okay, so here's my confidence interval for the variance. Here's my confidence interval for the standard deviation. Okay, and that does it for that one. Okay, 3 more examples. So number 4 says a sample of 61 Alzheimer's patients are tested to assess the amount of time in stage 4 sleep. The sample produces a mean of 48 minutes and a standard deviation of 14 minutes of stage 4 sleep over a 24-hour period of time. Compute a 95% confidence interval for the mean number of minutes spent in stage 4 sleep. So the thing about this section is that it provides you with good mixed practice, right? Provides you with an opportunity when you don't know, you know, which section the problem comes from. And so you have to read through the problem carefully to figure out, okay, am I constructing an interval for the mean, the proportion, or for the standard deviation? And in this case, it gives it away to us, right? It says in that very last sentence, compute a 95% confidence interval for the what? For the mean, right? For the mean number of minutes spent in stage 4 sleep. So we're going to be constructing a confidence interval for the mean. To do that, we go to stat, t-stats, one sample with summary. By the way, I forgot to check conditions here, but notice that our sample size is 61, right? So n is 61. That's bigger than or equal to 30, right? So that's enough for us to conclude that x bar is normally distributed, and therefore it's legal, right, for us to go ahead and construct this interval. When we go here in Statcrunch, we'll be prompted for the mean, which in this case was 48. We'll be prompted for the standard deviation. Give the video a pause, see if you can find the standard deviation in the problem, but it should be 14. We'll be prompted for the sample size, which I just wrote down a second ago, and is 61. And we need to tell it what confidence level we want. Okay, we want a 95% confidence level. Let's see what we get. So stat, t-stats, one sample with summary. Okay. There we go. All right. So we know for a fact that the sample produced a mean of 48 minutes. Based on that information, we're 95% certain that the true population mean amount of time that Alzheimer's patients spend in stage 4 sleep is somewhere between 44.4 minutes and 51.6 minutes. Okay, and that does it for that one. Let's look at number 5. Number 5 says, a recent study of 100 people in Miami found 27 were obese. Find the 90% confidence interval of the population proportion of individuals living in Miami who are obese. Okay, well, so as far as conditions are concerned, we have to check to make sure that n times p times q is bigger than or equal to 10. Or since we don't know p and q, we would use p hat and q hat, right? Well, this is a study of 100 people. 27 were found to be obese, so p is 27 out of 100. Or you could change that into a decimal, that would be 0.27. If 27% of people were obese, then I guess that means 73% of people were not obese. So you'd say, 73 out of 100, or you could change it into a decimal. But we need to see if this is bigger than or equal to 10. Ooh, that's kind of a close call. Let's see. 100 times 0.27 times 0.73. Oh, it's 19.71. So it works, right? That condition holds. So we can construct the interval. Let's do it. To construct this interval, we want a confidence interval for the population proportion. So we're going to go to stat, proportion stats, one sample, and We don't have any raw data, so we'll say with summary. We'll be prompted for the number of successes. In this case, out of our 100 people who were surveyed, 27 had the characteristic we were looking for, right? 27 were obese. So we have 27 successes out of 100 observations. We'll also be prompted for the confidence level. We want a 90% confidence level in this case. So let's go to Statcrunch and see what we get. All right, so we say stat, proportion stats, one sample with summary. We had 27 successes out of 100 observations, and we want a 90% confidence level. Okay, so there it is. So we get 0.197 to 0.343. All right. So again, to interpret this thing, we would say something like this. I mean, we know for a fact that 27% of people in this survey were obese. Based on that information, we would say we're 90% certain that somewhere between 19.7% and 34.3% of people living in Miami are obese. Okay, and that's it for that one. One more. This one says, in the first 2 months of a recent year, 94 car occupants were killed by airbags, and 61 of them were improperly belted. Construct a 95% confidence interval estimate of the percentage of car occupants who were killed by airbags while being improperly belted. Based on the results, is it safe to say that the majority of car occupants killed by airbags were improperly belted? Well, we'll answer that question once we have our confidence interval. Let's just focus on constructing that confidence interval first. So we want a confidence interval estimate of the percentage of car occupants. Well, percentage is really the same thing as proportion, right? So we want a confidence interval for the proportion here. If you were thinking standard deviation, because it's the only example we haven't done in a while, well, you were led astray, right? Because this one is asking for an interval for the percentage, or in other words, proportion. To find that, we're going to go to stat, proportion stats, one sample with summary. We don't have raw data, right? So we'll say with summary. We'll be prompted for the number of successes. In this case, we're told that 94 car occupants were killed by airbags. 61 of them were improperly belted, right? We're trying to construct a confidence interval for the proportion of people who are improperly belted, right? So that's the characteristic we're interested in. So we had 61 successes out of 94 observations. So X is 61, N is 94. We want a 95% confidence interval. So confidence level, 95%. Let's see what we get. Stat, proportion stats, one sample with summary. X is 61. Whoops. X is 61, N is 94. We want a 95% confidence level. There's our interval. Okay, so to interpret this interval, we would say we are 95% certain that the true, percentage of car occupants who are improperly belted when they are in a car accident is somewhere between 55.2% and 74.5%. So based on that interval, right, is it safe to say that the majority of car occupants killed by airbags were improperly belted? Well, what do we mean by majority? Majority would mean more than 50%, right? Based on our interval, is it safe to say that more than 50% of people killed by airbags are improperly belted? Well, the answer to that question is yes. Okay, because the lower bound of our interval is 55.2%. So at the very least, right, at the very least, we think 55.2% of people are improperly belted if they're killed by airbags. So, so that's a majority right there, right? So at the very least, we've got a majority of people. Okay, so the majority of people who are killed by airbags are improperly belted. Yes, we're 95% certain that that's true, right? Because this was a 95% confidence interval. So we're 95% certain. So I'm going to say that. Say yes. We're 95% certain that the majority of people killed by airbags are improperly belted. Now we could ask some follow-up questions where we ask to draw some inference based on that, like we could ask something like, well, are airbags unsafe? And you could argue, I guess, both ways and say, well, yeah, people are dying from the airbags. But on the other hand, you could say, no, because the reason they're being killed is because they're not wearing their seatbelts properly. If they're wearing their seatbelts properly, then the airbags aren't going to harm them, right? Anyway, other kind of follow-up questions could be asked there, I suppose. But that's the idea. Okay, so there's your homework assignment. Regardless of what the instructions say, feel free to use Statcrunch on any and all of the problems. Okay, so that'll do it for us. Thanks for tuning in.